Hey, what's going on, guys? Let's do this problem right here. The question is asking a proton with a mass of 1.67 times 10 to the power of minus 27 kilogram enters a chamber parallel to the floor with a velocity of 5 times 10 to the power of 5 meter per second. A magnetic field of 0.4 Tesla is directed from the ceiling. What will be the radius of its motion? If it has a charge of 1.6 times 10 to the power of minus 10 to the power of minus 19 coulomb. Let's see how we can calculate this one. But before we do that, we have to know the direction of the particle, right? So what happens is when a particle enters into this magnetic field, there's a force always going to act on the particle perpendicular to it, right? So when the force acts perpendicular to the particle will deflect, and when it's deflect, each time it deflect, the force is going to be always perpendicular to it. It causes go in a round motion. So that's what's going to happen, and we have to find the radius of that round motion. And let's draw the diagram for that one. So here, if we draw that, first they are saying the magnetic field is directed from the ceiling, right? So let's look at the bird eye view. So if we look from top, this is going to go outside, right? So going outside means dot. So that's what dot represents. And this particle is going in a rotation motion. So let's draw the particle like the rotation. And we have a plus charge. This is a proton, right? So this is a plus charge. And if you use right hand rule, right? So we have to direction of the magnetic field is outside, and then this is positive, so you have to use right hand. And if you direct your right hand toward the direction of this charge is actually going in the parallel to the floor. Okay, so this is going in this direction, right? 5 times 10 to the power of 5 meters per second. And if you direct your hand in this way and fold it toward this magnetic field's direction, that's going to give you direction of the force. And if you find that, that's going to give you this down direction. So that's going to be the direction of this force. And each time this particle deflect and go around, the force is going to be perpendicular to that particle. So we are going to have force like this. The question is asking to find the radius of this circle. So this is going to go in a circular motion. So the radius is the question. Let's see how we can find. So when we have radius, when we have a rotational motion, we are going to have centripetal force. So we are going to have a force in the middle that can be calculated by MAC. This is acceleration centripetal. So acceleration centripetal is equal to v square over r. So this is going to be mv square over r. Now we have in terms of radius. So we can find the radius using this one, and we can equate this one to the force by magnetic field. That is given by Fb is equal to QVB sine theta. And since this is always perpendicular to this force is always perpendicular to this particle, this is going to be 90 degree. So if the sine is 90 degree, this is always going to be 1. So we can, instead of sine theta, we can just write QVB. Now all we have to do is just equate these two equations, and from that one we can find the radius, right? So let's write radius as a capital R. So this is going to be mv square over r is equal to qvb. And if you notice, we have velocity in this equation and the other equation, so we can cancel both. And our purpose is to find the r, right? So r is going to be equal to mv over qb. Now we have all the information. We have the mass that's provided, 1.67 times 10 to the power of minus 27 kilogram times velocity is provided 5 times 10 to the power of 5 meter per second, and the charge is provided 1.6 times 10 to the power of minus 19 coulomb, minus 19 coulomb. This is B, right? This will be B, and B is 0.4 Tesla right here. So that's provided 0.4 Tesla, and if you calculate this value, that's going to give us 0.013 meter. So this is same as 13 millimeter. Now let's look at the units. Here we have kilogram meter per second, and you may ask, how did we derive meter from this one? So let's analyze these units first. We have kilogram and meter per second on top. In the bottom we have coulomb, right? And Tesla is equal to Newton per ampere meter. Newton per ampere meter, and we know that ampere is same as coulomb per second. So we can replace this one with coulombs per second. So coulomb in the bottom, second goes to the top. So this coulomb and this coulomb cancels, and we have this second right here, and also we have another second, so that's going to make this one second square. But the thing is, Newton is equal to kilogram meter per second square. Kilogram meter per second square is equal to 1 Newton. So this second and this second cancel with this second square, and if you notice we have meter right here, that's going to cancel with this meter, and kilogram on top, the kilogram on this one cancels, and that cancels the Newton. We are left with meter, and that's how we derive this meter right here, and that's how we do this kind of problems. I hope you guys find this video helpful. See you next time.